The next idea of improving buildings' energy consumption, water consumption, workability, livability, light, etc., is retrofitting, ranked at number 80 by 2050. But cost and savings are modeled in renewable energy, LED lighting, heat pumps, insulation, etc. So it's wrapped into that if the retrofitting cost is gone into it. So I've taken some data elsewhere to show what the estimated savings are in terms of operations and energy use and so on. The poster child for retrofitting to improve energy efficiency is the Empire State Building in New York City. So here it is an image. A receptionist sits behind the information booth during the 530 million retrofit of the Empire State Building, originally constructed in 1931. Apparently it went up in just 1 year and was just built to make it the tallest building in the world, and remained so well into the 1970s. Now there are many buildings claiming this title. The retrofit to the Art Deco icon saw a replacement of all 6,500 windows and all heating, cooling, lighting systems, and energy reduction of 38%. So that is going to pay off over time. Plus, apparently when we do retrofitting, occupancy go up, energy use, water use, etc. go up, and of course people come to see what has been done. So Empire State Building is a big tourist attraction, of course. From this site, worldgbc.org, expected operating cost decreases from green retrofit or renovations by year. So this is Dodge Data and Analytics 2018. So you can see the percentage of buildings and how much they saved in operational cost. There is more than 15% and less than 5% or so. So 30% of the buildings saved 5% or less, and then 27% saved 6 to 10%, and 24% saved more than 15%. By 2015, the number of buildings saving more than 15 was at 21, and then 2018 it was again at 24%. But within 5 years of operation, the same things go up by 42% here, 34%, and 40%. So over time, the operational costs savings keep going up, which is a good news because upfront costs tend to be high. Expected average payback period for Greenfield renovations by year, again going by percentage of buildings that estimated to get paid back of the cost in more than 10 years, is at 15% in 2012, 16 and 18 respectively in 2015 and 18, and 6 to 10 years and 1 to 2 years are the numbers here, 37, 39, 39, and 6, 8, and 8. The point is again that there are calculations made for paybacks and for the cost of decreased operational costs, and of course there is associated benefits of emissions reductions as well, which are not directly computed here for retrofitting but are included in the other associated items we saw in terms of LED lighting and green roofs and so on. Expected increase in asset value from a green retrofit or renovation project according to owners. This says according to owners because there is also an estimate by according to architects and designers, which tends to be somewhat higher than this. So you can see the various fraction of the estimates for different years here. So I don't want to spend too much time on the numbers other than to tell you that people actually worry about these things. Of course there are architects and designers and consultants and so on available to help you retrofit any building, and the Willis Tower in Chicago also has been retrofit since the Empire State Building, and I think now there are new ideas on taking clusters of building and renovating them, retrofitting them together to achieve the economies of scale, so that upfront cost itself is reduced, and then all the other benefits are still accomplished in terms of operational costs, reduced energy use, water use, increased occupancy, and so on. This is an estimate from BP talking about primary energy consumption by end-use sector, and I wanted to put it up here for 2018. Buildings are down here in terms of exajoules, and the increase per annum from 1990 to 2018 was about 0.5% for buildings, and is expected to go up if we do business as usual by 2050. It's expected to go up by another 0.3% or so. But if we go to these other sustainable development scenarios and net zero approaches and so on, the buildings will not add that much more. But the absolute energy use, of course, continues to go up in terms of exajoules, especially if we do business as usual. But it can rise just a little bit if there is net zero buildings being added. So the IEA, International Energy Agency, estimate of the total consumption by source of the OECD from 1970 to 2018, you can see that the buildings, which is in the green, have gone up substantially but have flattened out here since about 2010. Obviously, retrofitting is to bring it back down, so that's the main idea of retrofitting. Always obviously about returns on investments, and no external benefits or no external costs are assigned to benefits in terms of reduced emissions. So that's a co-benefit that's not always fully accounted. As with net zero buildings, there are no results presented from our models here. Building owners who retrofit existing residential and commercial building space install better insulation, improved heating and cooling equipment, upgraded management systems, etc. These solutions are accounted for individually in the various sectors we have already seen. No retrofit will look exactly the same because it depends on the climate, on the building, on the budget, on the original construction, and so on, making forecasting costs and savings nearly impossible. But nonetheless, retrofitting is ranked at number 80 overall, and it is hopefully a no-regret solution in terms of recovering costs, if not reducing energy use, emissions, and water use as well.